Now we're going to look at some more examples of the Gauss-Jordan. Just one example probably won't do. So I've got 3 more here, and we'll go ahead and get started. Put it in augmented matrix form. I've already got a 1 in first row, first column, so I don't have to do that step, but I've got to make a 0 here. Remember, we always work with the first column, and we use the first row to do our first step. So it's a coincidence there. I need a 0, so I'm going to multiply by the opposite. So I need to multiply by 3 to the top row and then add it to the bottom row to eliminate that or make a 0. Okay, I do not have it in my calculator. So let's go edit. This is a 2 by 3. So 1, 1, 4, negative 3, negative 2, negative 5. Second quit, second matrix. Let me check it. So I've got 1, negative 3, 1, negative 2, 4, negative 5. Alright, so let's go make this position a 0. Second inverse key, over to math, up, because I want multiply and add, so I want that particular item. 3, comma, second matrix for matrix A, comma, 1, comma, 2. Enter. I do have a 0 in the position I wanted, so let me store this. Store, second matrix, enter, enter. So it's there. So that's what should be on this one. Okay. So, oh nice, I've got a 1 here, so I don't have to do that very first step, getting a 1 in that particular position. But now I've got to use this row to make this a 0. So the opposite of that one would be negative 1. So negative 1 times row 2, add it to row 1. Second matrix, over to math, up for multiply, add, negative 1, comma, matrix, comma, 2, comma, 1. Store. Okay. So x sub 1 should be negative 3 and x sub 2 should be 7. Okay. This one, well, we'll keep on going. Put it in augmented matrix form. Now on this one, I do not have a 1 like I did in the other one. So that's my initial step, so I need to multiply this row by 1/7. So let's see if I did that. And then go ahead and complete what you need to do to that to get the column like it needs to look. So I'm assuming once I've done this, I'm going to have a 1 here, and I'm going to multiply that row by the opposite to get rid of this one. So I'm going to multiply 2 times row 1, add to row 2 to get my new row 2. So I've got to go put in my new matrix. Let's go edit. It's already a 2 by 3. So I've got 7, negative 8, negative 9, negative 2, negative 5, 6. Second quit. Let's go check my matrix. So I've got 7, negative 2, negative 8, negative 5, negative 9, and 6. Alright, so now let's go do our steps. Second inverse key for matrix, over to math, up, and I need just the multiplication first. So I've got 1 divided by 7, tell it the matrix, and then the row. And I got a 1, nasty looking decimal, but I do have a 1 where I need it. So store, second matrix, enter. Next step, got to get a 0 here. So second matrix, or second inverse, to get the matrix key. Hopefully you know what I'm talking about by now. Add, multiply, add. So I'm going to 2, comma, tell it the matrix, comma, 1, comma, 2. Hopefully you'll notice why this was very important, because this tells you exactly how you have to input it into the calculator. Let me hit enter. So I do have my 0 there. So store, second inverse for matrix. Hit enter. Nasty looking stuff, so let's go frack it. And it won't be as nasty. Let me delete my box. So there it is. So now, first column's complete. I'm working in my second column, and in the second column I've got to go to second row, second column element, make it a 1 by multiplying by the reciprocal. So I'm going to multiply row 2 by a negative 7 over 51. Come on, box. Maybe I had 2 boxes there. Ah, there it is. So negative 7 over 51 times row 2 for my new row 2. And then I'm assuming I will have my 1 once I get that completed. So I need to make this a 0. So I'm going to multiply row 2 by 8/7 to eliminate that position. Alright. So let's go. Negative 7 over 51. All I'm doing here is multiplying. So 7, whoopsie, negative 7 divided by 51, comma, second matrix, comma, row 2. See if we get our 1. Yep. Store, second matrix. Remember, you're going to have to hit enter twice when you store these. So the second thing I've got to do is get a 0 in that position. So second inverse for the matrix key, over to math, up for the multiply add. 8 divided by 7, comma, second matrix, comma, 2, comma, 1, end. Please don't give me this answer. Let's go frack it. Math frack. So let's see if that's what I've got here. Alright, so x sub 1 should be equal to negative 31/17, and x sub 2 should be a negative 8/17. Nice. Alright, let's go do 3 equations, 3 unknowns. Now there's something I need you to see here. Notice that I'm not taking the matrix exactly how it looks. The equations exactly how it looks to put it in my augmented matrix. I will look to see if I have an equation that starts off with a coefficient of 1, because that's one less thing I have to do. So I'm putting the second row as my first row, so I'm just really interchanging these two. You can do that in the calculator, but why bother? Go ahead and put it in like you need to at the beginning. So let's go put this into our calculator. And this is 3 by 4. So I've got a 1, negative 1, negative 5, negative 2, 2, 3, 5, 21, 2, 1, negative 1, 11. Second quit, second matrix, second inverse for matrix. Enter, enter. So check by column. 1, 2, 2, negative 1, 3, 1, negative 5, 5, negative 1, negative 2, 21, 11. Okay. So I've already got a 1 in first row, first column. So I need to make these 0. So I'm going to multiply row 1 in both situations by negative 2. So negative 2 times row 1 to add to row 2 for my new row 2. And negative 2 times row 1 add to row 3 for my new row 3. So second matrix over, up to multiply, add. So I need a negative 2, comma, second inverse for matrix, comma, 1, comma, 2. There's my 0. Store your matrix. Now I'm going to show you something that might be a little bit quicker. The only difference here is that I need row 3 as opposed to row 2. If you do second enter, it's sort of like it twists back, sort of a recall. So let me go here. I'm just going to change this to a 3 and then hit enter. There. Store second matrix. So column 1's done. So let's see if this is what I've got here. I think so. Very good. Alright, so now we're at the second column. So let's go make second row, second column element of 1 by multiplying by, hopefully you said 1/5. We're going to assume that will occur. So now I'm going to go ahead and make my plans to make zeros in the other position. Opposite of this is a 1. So 1 times row 2, add to row 1 to give me my new row 1. And a negative 3 times row 2, add to row 3 to give me my new row 3. Let's go. Second. So first thing, make that position a 1. We only can do that by multiplying. So 1 divided by 5. And we're playing with row 2. There's my 1. Store it. Second matrix over. I'm just going to say second matrix. It's just quicker. I'm getting over it. Alright, so now I'm going to do 1, comma, second matrix for A, comma, 2, comma, 1. Store it. Let's go do second enter, second enter. Let's see if we can modify this. I need a negative 3. So let me do an insert, negative 3, and then I'll do a delete. And I've got the 2 already. Whether this is faster or not, I don't know. Well, it doesn't help if I go beyond. You might find it faster. Oh, cool. Got a row of zeros. Yep. Now, I'm going to write this out because this is something that we do end up with every once in a while. Now, if you remember when we had a row of zeros, or we had 2 equations that completely, when we did the elimination method and one completely got wiped out, remember these, those lines were the same line. So it means one of these equations is the same. So if I wrote this out in equation form, I would have x sub 1 minus 2x sub 3 would equal 3. Well, this means an infinite number of solutions. Like I said, we can go a step further. Alright, so I'm going to write the equations first. We start with x sub 3 equal t. We always let this very last one. See, I've got something for x sub 1 and x sub 2. Okay, so x sub 3, since it got completely wiped out, in a way, you can let it let it be represented by a letter. But the rest would then look like this. X sub 1, I just went straight back up. X sub 2 plus 3x sub 3 would equal 5. Remember that x sub 3 is equal to t. X sub 1 minus 2x sub 3, notice this is my first equation up here, would equal 3. But then, if we let x sub 3 equal t, like we did a few minutes ago, these things change to this. Put a t here and solve for x sub 2. Then you would end up with x sub 2 equals negative 3t plus 5. X sub 1 would equal, once you add this to the other side, 2t plus 3. And then we could write it like this. X sub 1 equals 2t plus 3. X sub 2 equals a negative 3t plus 5. X sub 3 equals t, or whatever letter you want. Now, remember that we had an infinite number of solutions. So if I let t be 0, that means x sub 3 would be 0, x sub 2 would be 5, x sub 1 would be 3. That would be one possible solution. What if t were 1? So x sub 3 would be 1, x sub 2 would be 2, and x sub 1 would be 5. So we could do this what if for like ever, because t could be anything we wanted. That's why it's called an infinite number of solutions. Okay? You might have some of these. I believe you will. And that's it for this particular video. Thank you. Bye-bye.